Okay, I have something. Let's see here, right here. Revised miles per gallon ratings. Listed below are the combined city highway fuel economy ratings. The old ratings were based on tests in 2008 and the new were into effect. So, can we prove a linear correlation, and then do we want to make a regression line for it to predict other values. So I have old and new. So the first thing I want to do in StatCrunch is I want to import my data, obviously. The nice thing is if you're doing this in my math lab, you might be able to open straight into StatCrunch. If you can't, just open in Excel and copy and paste it. Okay. I always make sure that I label what I'm doing, and I usually even add in here the X and Y. Okay. And sometimes they'll tell you specifically, you might choose one or the other based on how you want to do it. It really doesn't matter which is X and Y in general, but the typically way it goes is that Y is your output variable and X is your dependent, what you control. So I pick the old, and then the new is what comes out of the system. So that's usually how it's done. It's just like if you were testing a medication, I can control how much of a dosage I give the patient. The outcome, is whatever we're hoping for, whether it's a reduction in temperature, a reduction in pain level, that is the output. So in general, when you're deciding what to go, X is the dependent, the independent, what you control, what you can vary, and Y is the dependent, what you hope is being affected by X. This is a little wonky because it's just old and new ratings. It's really just a transformation. Either would probably work just as good as the other. But in any case, I do try to make sure I label so I know what's what. Then I'm going to go to stat. I'm going to go to regression, and I want simple linear. Okay. Then I'm going to match up. And again here, making sure you make it make sense. This is all fine. But actually, I can do this prediction. Show you what happens. So. Okay, couple things I got going on here. First of all, this right here is my regression line. So 0.808, that's my intercept, and then my slope is 0.863. And then I have it times x, which you can see here. By doing this, I can see it's got old x, so I can see that in there, and then y is my sample thing. You can see my correlation coefficient. My R is there, 0.998. It's really, really high. It's almost a perfect correlation would be 1. So I can definitely use this regression line. Now officially I'd want to, of course, look up the Pearson R and compare it, but given that's so high, I can kind of look at that and do it. But officially you should look it up in the Pearson table, and you might very well be asked for that value. Now you can see it does even tell you the p-value for each specific piece of it. So like this one, it's really certain of. That one, not so much. It's almost 10%. But it does do that individually. Then down here, what it's doing is it's doing the predicted y. So what it did is it's putting in the 33 and factoring it into the equation. You can see here they even do a confidence interval and a prediction interval for it. So it's got some pretty cool things to explore, and you might want to look at those for later ones. But in general, what you would do is I would take that 33 and I would put it in for x. So I would get 33 times point, let's just round, so 863, it's not what I just put into my calculator, and then I'd add 0.808, and that's how they're getting this 29.29. That's that value. They're just plugging in that and computing it, but it does it for you, which is kind of cool, especially since that's one of the options on the project, and you have to do a prediction. So it will even help you with that, though it's not that hard to plug it and do it yourself because it's just a straight, point slope formula. Hopefully, though, this helps you with this process. And you can see here they even give you the fitted line. So this is the scatter plot, and then they show you how it matches that. And you can see that matches pretty darn good, but we would expect that with a Pearson R of 0.998. So hopefully this helps you. You can see this does a really nice job. It's really just making sure you label so that when you read the output, you know which piece goes with which. I think that's where the biggest mistake can be, is in that labeling. And again, make sure you're paying attention to that dependent versus independent. If they don't tell you, a lot of times they'll tell you what X and Y is. If they don't, though, that dependent and dependent is kind of how you tell.